We've talked before about the biggest stars in the galaxy, and we've told you about the smallest. But then there are stars like Eta Carinae A, a star so massive that it seems to defy the laws of physics. Eta Carinae is 5 million times brighter than the Sun, one of the brightest stars in the galaxy. It's so luminous that its gravity can barely contain the outward-pushing pressure of its radiation, so it's constantly shedding mass, and yet it's still about 90 times as massive as the Sun. With all these freaky features, this star, the larger of the two stars in the Eta Carinae system, have been dazzling astronomers for centuries. For observers here on Earth, things started to get weird with Eta Carinae A back in the early 1800s. It started flickering faster and faster, like the warning light on a bomb that's about to explode. Then, in 1837, it suddenly erupted, pouring out so much gas into space that it lost nearly the equivalent of the mass of the Sun every year. Throughout this eruption, it grew in brightness until it was the second brightest star in the sky, and stayed that way for more than 20 years. Eta Carinae A released nearly as much energy as a supernova, but at a slower rate. By the time its outburst was finished, it had released so much gas and debris that it actually created a nebula around itself. Nearly a century later, Argentine astronomer Enrique Gaviola called it a homunculus nebula, because apparently he thought it looked like a plump little man. Eta Carinae is an example of the most extreme types of stellar heavyweights, stars that are among the most massive in the galaxy, with luminosities that are millions of times higher than the Sun's. And since their surfaces are tens of thousands of degrees, these stars appear to be blue. So astronomers call them luminous blue variables, or LBVs. Stars this massive tend to go through huge outbursts like Eta Carinae did, but catching them in the act is tricky. That's because these outbursts are only a short phase in the already short lifetimes of these extreme high-mass stars. Keep in mind, most stars, including the Sun, lose some mass through their stellar winds. But LBVs are the biggest losers, sometimes shedding half or more of their original mass through the combination of their winds and catastrophic outbursts. When an LBV is at its brightest, so much light comes blasting out that the outer atmosphere of the star acts like a kind of solar sail, carried away on an unbelievably powerful stellar wind. This could be what happened when Eta Carinae A erupted in the 1800s. Since then, astronomers have continued observing Eta Carinae and have been able to make highly detailed 3D models of this funky-looking homunculus nebula. Today, these models help untangle how the streams of hot ionized gases flowing from the star interact with each other. And it's one of the few astrophysical structures that has been fully modeled in 3D. You can even download the model and 3D print your own homunculus nebula. But there are still a lot of questions that we can't answer yet, like how exactly the LBV phase fits into the end of a high-mass star's life. Plus, we don't even know how these ultra-high-mass stars form in the first place. But we do know that some formerly LBV stars have gone supernova soon after they erupted. So, Eta Carinae may still have one more explosion in the works, which means we may have one more amazing spectacle to look forward to from one of the most unusual stars in the sky. Thanks for watching this episode of SciShow Space. If you'd like to learn how you can help us keep exploring the universe together, go to subbable.com/scishow. And don't forget to go to youtube.com/SciShowSpace and subscribe.